Hi everyone, welcome to video 13 where we're covering the Check Your Learning exercise for one way within subjects ANOVA. We're looking at the question, do people report different levels of prejudice towards terrorists, drug dealers, and prostitutes? So we have one group, one sample, and we're comparing more than two mean scores within that same group or sample. So we're doing it one way within subjects ANOVA. And here we're comparing prejudice towards terrorists, drug dealers, and prostitutes. Which makes sense in a way here, right? Because all these different groups have committed a crime, right? Broken the law, except for prostitutes. I know, in the outlying areas around Las Vegas, prostitution is legal, but everywhere else in the U.S., you'd be arrested and prosecuted for these crimes. So are people going to report different levels of negativity towards these different social groups? And before we look at the main ANOVA output, we want to make sure that our Cook's D values look okay. And here we see a nice progressive gradual decrease in Cook's D values after we've sorted them descendingly. This is what we want to see. They look good. There don't appear to be any outliers. And then we also want to check Mauchly's test of sphericity, and we want Mauchly's test to be non-significant. And so if we zero in here to the p-value, the sig value for Mauchly's test, it is 0.24, and so 0.24, non-significant, so that's great. We actually have met the assumption of sphericity here. So when it comes to pulling numbers from the ANOVA table, the Tesla within subjects effects table here, well, we're going to pull numbers from these sphericity assumed rows. Now in the lecture example, Mauchly's test was significant, and so we pulled numbers from the greenhouse geyser rows. Here, again, Mauchly's test is non-significant, so we're going to pull numbers from the sphericity assumed rows. So let's get to the first couple paragraphs here. We're looking at differences in prejudice toward terrorists, drug dealers, and prostitutes. For this, we conducted a one-way ANOVA, one way within subjects ANOVA to assess whether participants, and here we need big N. So here N equals 133. So that's whether participants, N equals 133, reported different levels of prejudice towards terrorists, drug dealers, and prostitutes. Right, so that's the first paragraph. We'll move on to the second paragraph where we are doing the ANOVA test, talking about the ANOVA test, the F test. And so we'll start with filling in the F stats here. So we have F, and then in parentheses, we're going to put degrees of freedom between and within. And again, we're pulling numbers from the sphericity assumed rows here. So DF between is 2, within 264, so 2, 264. Equals, and then our actual F value, which is 53.64, 53.64. And then P, that's a big F value, so I'm assuming we got the triple zeros, and we do. So we'll denote that as P less than 0.001. And our P value is significant. So our F value, our ANOVA, is significant. So results showed a significant main effect of social group. And because we have a significant main effect here, our F test is significant. There's at least one significant difference between the mean prejudice scores for terrorists, drug dealers, and prostitutes. Right. And looking at the partial squared value can give us a sense of how big these differences are. So our partial squared value here is 0.289. So type of social group, whoops, here we go. Partial squared equals 0.289. So the type of social group explained 28.9% of the variability in prejudice scores, which is a large percentage. So the type of social group here seemingly had a big effect on how much prejudice, how much negativity people reported towards these different groups. So we'll probably see some big differences here between the mean prejudice scores. And so to find out which group significantly differed, we'll have to look at the post hoc tests. And before we start looking at p-values, calculating these, let's fill in our descriptive statistics here. And so the first sentence here, we have terrorists and prostitutes. So let's get the mean and standard deviation prejudice score for terrorists. So we'll look at the descriptive statistics table here, prejudice towards terrorists. And so we have 7.82 mean score and a standard deviation of 1.0. Well, actually, the 7 rounds up to 9, so 1.10. So 7.82, 1.10. And the response scale is actually here 1 to 9. So we're definitely in the upper end of the response scale here. People are reporting pretty strong negative feelings towards terrorists. So let's copy the mean and standard deviation over. And then we have prostitutes. And so mean is 6.27 and standard deviation 1.58. 6.27, 1.58, 6.27, 1.58, just make sure. And then we can copy and paste this over. And then lastly, drug dealers. 6.93 and 1.71. 6.93, 1.71. Go. And then we'll copy and paste that over. So if our means and standard deviations filled in, so now let's find the p-value for the first comparison here, terrorists and prostitutes. So we'll need to go to the post hoc table. Here's our post hoc table, and you can see that the social groups, the variables, are represented by numbers. So that's a big clue that we're doing it within subjects ANOVA here. And so the table, the key for the different numbers is over here. So 1 equals prejudice towards terrorists, 2 prejudice towards prostitutes, and 3 prejudice towards drug dealers. And so we're comparing terrorists and prostitutes right now. So that's 1 versus 2. 1 versus 2 here, and so the p-value here, we get the triple zeros, but you can see that we get the triple zeros for all the comparisons basically here. So 1 versus 2, triple zero, so that is p less than 0.001. I see that the p-values are going to be less than 0.001 for all the different comparisons here, so I'm just going to fill them in. Right, so prejudice, prostitutes, there is a significant mean difference in prejudice towards terrorists and prostitutes. We can see that the mean score for terrorists is numerically bigger than the mean for prostitutes. So 7.82 minus 6.27, that's a positive difference. And so we can say that participants reported significantly higher levels of prejudice towards terrorists versus prostitutes. And so we'll calculate the D's for all the mean differences here after we handle the p-values. Because just because you have a significant difference does not mean that difference is important or meaningful, right? We have to calculate our d-values. All right, so the second comparison that we're making is terrorists and drug dealers. And so terrorists and drug dealers, so this would actually be 1 versus 3, 1 versus 3 here. And so we can see that, again, we get the triple zeros here. So p is less than 0.001, but I would just point out the difference, how we find that difference in the post hoc table here. Right. And so we have a significant difference. So here, terrorists is listed first, then drug dealers. And so numerically, the mean for terrorists is bigger than the one for drug dealers. So we can say participants reported significantly higher levels of prejudice for terrorists versus drug dealers. And then lastly, we have drug dealers versus prostitutes. And so this would be 2 versus 3 here. So 2 versus 3. We get the triple zeros, so we can denote that as p less than 0.001. And again, I will point out, just as I have for the between subjects effects videos and the lecture example for the within subjects effects, right, there are redundant comparisons here in the table. So if we're comparing 2 to 3, we can also compare 3 to 2. We would get the same information. It's just that in one comparison, the difference is positive, and in the other comparison, the mean difference is negative. So 2 versus 3 here produces a negative difference, so we know that 2 must be smaller than 3. And here 3 to 2 produces a positive difference, so 3 minus 2 must produce produces a positive difference, so 3 must be bigger than 2, right? 2 must be smaller than 3, meaning that people must be reporting more prejudice towards drug dealers than prostitutes. And we can see that in the table here, that people are reporting more prejudice towards drug dealers than prostitutes, and we can again see that in our sentence here. We have prejudice towards drug dealers listed first, 6.93, versus prostitutes, 6.27. So we can say that participants reported significantly higher levels of prejudice towards drug dealers versus prostitutes. Okay, now to calculate the d-values for each of these comparisons. Just like for the lecture example for within subjects effects and the videos for between subjects effects, ANOVA, we need to find the mean square error in the ANOVA table in order to calculate S pooled. So we need to take every mean difference, divide by S pooled, spooled. In order to calculate spooled, we need to take the square root of the mean square error in the ANOVA table. So here, the mean square error, here, because we're looking at this first city assumed row here, is 1.51. So we need to take the square root of 1.51, bam, and so that gives us 1.23, 1.23. So we're going to take every mean difference and divide by 1.23. Again, we took the square root of the mean square error here, and that gives us 1.23 for S pooled value. So the first difference here, 1 versus 2, prostitutes versus terrorists here, the mean difference is 1.53, or 1.55, pardon me. So 1.55 divided by 1.23 gives us a d value of 1.26, big D. And we'll keep that D positive because numerically the mean for terrorists, the mean prejudice score for terrorists is bigger than the mean prejudice score for prostitutes. All right, so the next comparison here is terrorists versus drug dealers. So terrorists versus drug dealers, 1 versus 3. We have a mean difference of 0.90. 0.90 divided by 1.23 gives us 0.73. 0.073. 0.73. So technically a medium effect, but almost a large effect. So medium largish. And then finally we have drug dealers versus prostitutes. And so drug dealers versus prostitutes, so that's 2 versus 3. The mean difference here is 0.66. 0.66 divided by 1.23 gives us a difference of 0.54. And again, we'll keep this D positive because the mean for drug dealers is numerically bigger than the mean for prostitutes. So that's the post hoc table. So all we're left with is the conclusion. All right. So writing this conclusion, we have a D value here that is smallish, barely medium. We have one D value that is mediumish, almost large. And then we have a pretty huge difference here. So, if we said something like, participants reported much more prejudice towards terrorists than prostitutes and drug dealers, I probably wouldn't quibble with you all that much, given that the D value here between terrorists and drug dealers is medium largish, right? So you could say something like that. If you wanted to split up the comparison between terrorists and prostitutes and terrorists and drug dealers into two separate sentences, that would be also okay. So if you want to do participants reported much more prejudice towards terrorists than prostitutes, you can say participants also reported maybe fairly more, or drug dealers. And then lastly, participants reported moderately more, or somewhat more prejudice towards drug dealers than prostitutes. So again, we're using these qualifiers here to denote how big the differences were here. Oops, small prostitutes. There we go. So a little bit longer, if we split them up into three separate sentences. But again, we have three different comparisons, so sometimes we'll need three separate sentences, unfortunately. All right. So that's it for the Check Your Learning exercise. I'll post a link here in the PowerPoint, and then if you want more practice, I have included another within subjects, one-way within subjects ANOVA exercise here. We're actually comparing prejudice toward Christian fundamentalists, NRA members, and then pro-lifers. And so if you want to do this exercise, and then I have the results written up there. So if you want to write out the results and then compare your results to the one here, you're more than welcome to do that. So you can do 3 practice problems before you see the one on LQ number 9 or 10. Maybe it's 10. I think it's 10. No, I think it's 9. It's 9. Anyways, there's more practice if you want it. And that ends our videos for one-way ANOVA. On Wednesday, we will move to talking about two-way ANOVA. So until then, talk to you later.